First question. Write the mesh current equation for the left-hand side loop. So, what we're gonna do over here is that we're gonna take this, and we are going to transform. We're gonna 100 angle 0 is just 100. So 100 plus minus 10. The resistor will stay the same. The inductor will be like this, and then right after the inductor there's gonna be a dependent voltage source over here connected like this, dots over here, and this is gonna be inductor dependent source. Okay, like this. अच्छा, अब ये resistor आ गई यहाँ पे. We're gonna have one resistor, a capacitor, and done. The only thing I did was that I put a voltage source, a dependent voltage source, right after the inductors.
And that's just the rule?
Yeah, that's just a rule.
For magnetically coupled.
Exactly. And I'm going to draw currents over here. So I1, because look, I1's going like this, right?
Yeah.
They give you the directions. So I1's going like this. I2 is going to be going like this. And now to figure out the polarity on these voltage sources, because I don't know which side is plus, which side is minus, I'm going to look at the dots. So to find the polarity.
What is the dots?
The dots right here. This is a dot.
Okay,
and,
yeah.
This is the dot.
Yeah.
So basically, to find the polarity of this one, I'm gonna cover this one, and I'm only gonna look at what current is going through here. So over here, oh my bad, and there's this J5 thing over here. J5.
What is J5?
It's just this, like it's just gonna give you this, and I'll show you what it means.
Okay.
So basically,
so the first step is you redraw the circuit.
Yeah,
with the
redraw the circuit
dependent
like
voltage
this.
source.
Yeah.
What if there was a capacitor?
What do you mean? No, it's always with
There's a
inductors.
capacitor on the other side.
No. It's like, what if there's a capacitor? I'm like, it's never. You can never have a mutual inductance with a. क्या बोलते हैं इसको? With a
Magnetically
capacitor. So basically, so now you see this current is gonna be going like this. So current is gonna enter whichever side current enters. That's the plus side basically. So it's gonna enter the plus side, and you're gonna look at this dot over here, and this dot you're gonna go back to this. It's in the plus side, so there's gonna be a plus, minus, and you're gonna just take this, put it over here. Plus,
So one
minus.
more time with the dots, bro.
Yeah. So when the current is going into, that's the plus side.
Okay.
So wherever, remember I told you to get the sides over here, you look at this. So this dot is gonna be a plus, right?
Yeah.
So my bad. This thing was actually supposed to be like this. Like this. It's pointing towards the dots. So plus. Plus comes first, minus comes last. So plus comes first, minus comes after.
So this is a plus.
Yeah.
And then this becomes plus.
This becomes plus in this case only. So now when we're gonna be finding the polarity of this dependent source, so you see this I1 is coming like this, and I2 is coming like this, right? And if I say, okay, this side is gonna be like the plus side, like this side current is gonna be going down, so it's gonna be I1 minus I2, right? Because I1 is going in this direction, I2 is going out like that direction, right?
Right.
So I1 minus I2. Oh yeah, my bad. And I had to also say that the plus minus, the value over here is just gonna be J5 J5 I1. Yeah, J5 I1, because J5 was this factor over here, and I1 is this current over here. Okay, so now I1. So now look, this is going down and plus again, so this side is going to be a plus. So now we're going to go back to this, so plus minus, so plus comes first, minus comes after.
Wait, it's going down. What do you mean it's plus?
So you see this current is going down over here, right?
Right.
So it enters the
Plus first?
it enters means plus. So it enters plus, and hey look, there is a dot over here.
It was what's it? I1 minus.
Yeah, and look, hey look, there's a dot over here.
So whenever it enters, it's
Exactly.
plus.
So now you're gonna bring this thing back to the dot, plus, so plus minus, so plus comes first, minus comes after. That's how you get the polarity. And to get the value of it, this is gonna be J5 5 multiplied by I1 minus I2 because the current over here is I1 minus I2.
Okay.
And the current over here was
I1.
is I1 because the current over here is I1.
Okay.
You can look at the currents.
Yeah.
So you got this now, right? We're done.
So now
ab dekho. And
Wait,
now-
can you explain
yeah.
why it's I1 here one
Yeah,
more time?
it's I1 over here because remember I said that to get the polarity over here, you look at this inductor and you look at the current through this inductor. The current through this inductor is I1. To get the current and stuff in this one, you look at this. The current over here is I1 minus I2, so the value for the dependent source over here is going to be I1 minus I2. So now we got this. So now it says to write the mesh current equation for the left hand side loop, right? So now this is a straightforward KVL. So it's negative 100 plus 10I1 plus what's the equation for the voltage across the capacitor inductor?
L times di over dt.
Yeah.
Oh, so J10. Oh, my bad. This is already in thing form, J form. So you just write J10 I1
I1 minus I2, isn't it?
Okay, so you can
Plus-
just multiply by.
Yeah, isn't it I1? Oh no, it's only I1.
plus
Yeah.
this J5. So J5 I1 minus I2, and then plus this. So this is gonna be J. What is this? J10 plus J10. This is also going to be I1 minus I2 because the current
It's
over
in the
here.
middle, right?
Yeah, it's in the middle
Yeah.
because it's in the middle, and plus J5 I1 is equal to 0. That's that's your number one, and you could simplify this and get like your I1s and I2s on each other side, and you got five marks right there. Done.
And then that's what you do on the right side. You solve it for the other mesh.
Yeah, ठीक है. अब हम move करते हैं second question पे.
बंगाली में बोलो.
Habisha bolo. Second question. Let's get this.
Oh, whoa.
Was that right?
I don't know, but
No.
I don't even know what you said.
What language is that?
I was like, whatever.
Whatever.
I
So
still
now,
don't even understand.
so now write the mesh current equation for the right hand side loop. So now we're just gonna do this side, right? So this side is gonna be minus, cause it's minus, right? Minus aa raha hai. Minus J5 I1 plus J10 I2 minus I1 because now we assume that this is the thing side plus 10 I2 plus what's the voltage?
Isn't it minus?
What do you mean?
Minus J10.
Oh yeah.
It's the integral
Oh yeah.
1
No,
over
it's just,
c.
it's just minus J10 because it's
Oh
already
yeah,
in the J form,
yeah,
right?
yeah.
Is equal to 0, and that's
Wait.
it.
Why didn't you change it to the thing?
Because this is when you have it in J or S form,
Okay.
you don't have to change it. That's
Change
only
what?
change like
Two capacitor thing.
yeah, that's the voltage.
But
When
that
it's in
was
no,
on
my
J2.
bad. When it's in J or S form, you could add
Isn't
and
it
subtract like
minus
resistance.
J10 multiplied by the current?
Oh yeah, my bad.
Wait,
I
then why
too.
didn't you do it on the previous one then?
Okay.
What do you mean? I did do that on the
No, you
previous
did it.
one.
You times the inductor. Where's the inductor one?
Right here,
Where was it?
10 I1, J10, 10 I1.
Wait, didn't you say it was inductor for D? Wasn't it L times?
No,
D?
but
Fam, it's in J form. If it's in J form, it
Yeah.
acts like a
So
resistor.
remember impedance?
It's like a load.
So basically,
Yeah,
in this
impedance
question,
form.
so
Yeah,
basically,
remember
you did-
impedance?
Yeah.
Yeah, you treat everything like a resistor, just I times whatever.
So
What?
basically, yeah. So you basically there's no like DI, DV,
No,
and magnetically coupled.
Okay.
Yeah, whenever you have
Yeah.
the J form,
Yeah,
you want that.
yeah,
So
yeah.
whatever
like
it
the
is, you
impedance.
multiply I1.
Yo, just know this:
Yeah.
for magnetically coupled
There's
circuits,
no-
I'm pretty sure they're gonna give you these values, straight up add them.
Okay, same.
All right, you got your thing for this side, and let's double check if you got it right.
Okay.
So we go over here. Check is a blessing, alhamdulillah.
Less tool.
So magnetically coupled circuits. So now these guys got 10 I. Well, I'm just gonna double check. So 100, yeah. So minus 100 is equal to 10 I1 plus J10 I1 plus J10. The flip. I got J5. Oh yeah, J10 I1 minus 2 plus
J5,
J5.
same thing.
Yeah, okay. And for the second one, they got
What did they get? Read it.
I2 times 10.
I2. Yeah, I.
Oh yeah, right here.
I2 times 10.
Yeah.
Which one are you reading?
This
Go
one.
down?